The question is difficult because the answer depends on how consciousness arises in the physical world. And we don't know the answer to this question. We have no clue how my consciousness is associated with my brain. We know that there are law-like connections between certain mental states and certain physical states, and we exploit them for certain psychoactive drugs or medical applications. So we know there is a certain law-like connection between the brain and the mind, but we don't know exactly what the nature of that relation is. Is it a causal relation? The brain causes the mind. Is this maybe identity, that the mind is simply identical to the brain? Or there are several other candidates of that relationship between mental properties and physical properties. That is called the so-called hard problem of consciousness. We don't know how consciousness comes into this world. And since we don't know the nature of consciousness, we have no clue how to build a machine that is conscious. If we knew the nature of consciousness, we would have a blueprint how to build a machine that's conscious. Let's look at two different theories of consciousness that are currently being entertained in the science of consciousness. The first one is so-called integrated information theory, IIT, theory of consciousness of Giulio Tononi. Here the idea is that there is a law in this world that says something like this. If in a system information is processed in a specific way which we call integrated, then the more information is processed in an integrated way, the more consciousness arises in that system. Integrated information is then defined in that theory. It's different from information processing in standard computers, which is sequential, algorithmic. It's more holistic. It has certain features that the whole is more than the sum of its parts. There's a certain element of the emergence of higher level wholes that should reflect the unity of consciousness as we experience it. And this is all developed in a very advanced mathematical model in this theory, but the theory is testable. We can measure this amount of integrated information called phi, and we, for example, could measure phi in the brain of a patient who is in a coma, and then we could, if the theory is correct, deduce from that measurement whether this patient is still conscious and to what extent they are conscious. If this theory turned out to be correct, then we know how to build, in principle at least, a computer that's conscious. We have to build a machine that processes information in an integrated manner, so that phi, the amount of integrated information in this machine, is relatively high, like in an animal or even a human being. At this point, we don't have enough understanding on how to build such a machine. But if the theory is correct, at least we know where to look. And we might in the future be able to build such a machine, and then also know, because we can measure phi, the machine has a certain amount of consciousness. Well, there are completely different competing theories. Many of them, or some of them, are built on the idea that consciousness is somehow connected to quantum mechanics. For example, in the theory of Penrose and Hameroff, each collapse of the wave packet in quantum mechanics is a single moment of consciousness. This is built deep into space-time. Even at the very low level, whenever there's such a collapse, there's a tiny little speck of consciousness. Well, if in a complicated brain all these tiny little collapses are integrated and orchestrated into very large wholes, then these collapse events create an integrated whole, what we call our normal consciousness, as you experience it right now looking at this presentation. If this theory is correct, and in this theory a conscious experience is identical to a quantum mechanical collapse of the wave function, if that theory is correct, we would have to exploit these quantum mechanical processes, build a quantum computer in which very complex large superpositions and very complex integrated and orchestrated collapses take place. And these computers, if the theory is correct, would then be conscious. So these two examples illustrate that the question whether we can build computers that are conscious depend on whether we are able to develop a theory of how consciousness arises in the natural world. And since we don't have a theory that's generally accepted at this point about how consciousness arises in the physical world, we don't know yet whether we can, and if we can, how we should go about building a machine that has consciousness as one of its properties. So it's the lack of our understanding of the nature of consciousness that leads directly to our inability at this point to build machines that are conscious.